Okay, so first let's talk about the product rule for logarithms. It says this. If I have log with a base of b, and I am multiplying two entities together, like say m and n, I'm allowed to expand this logarithm over addition. So I'm allowed to break this up as log base b of m plus the log base b of n. So this is what the product rule says. They call it product rule because when you multiply two logarithms together, you're allowed to expand over addition. So find that product rule on the cheat sheet, make note of it, say, yep, there it is, that's the one that we're going to use. And I'm going to give you a few examples of directly the product rule of how it works. So for the first one, if we have, say, log base 4 of 2x. So I am multiplying 2 and x together, log base 4 of 2x. So I'm allowed to say, all right, this is the log base 4 of 2 plus the log base 4 of x. And that is the proper way to expand log base 4 of 2x for the product rule. What do you guys think? It's easy, medium, or hard so far? Pretty easy, right? Okay. If I have the log of 10x. Now again, there's no base right there, so what are you allowed to imply? It's a base 10. Very good. So I can say this is log base 10 of 10 plus log base 10 of x. You do not need to write the base 10 in there. You get that one for free. So whenever there's a base missing, you're totally allowed to assume that it is a base of 10. You totally can, yeah. It's not wrong. This also works for logarithms that have a base of e or natural logarithms. So we could say the natural log of 2x is the same thing as natural log of 2 plus the natural log of x. After all, this just represents some number. So we're allowed to write this as natural log of 2 plus the natural log of x, because all rules that apply for natural logs also apply for logarithms, because a natural log is just a log with a base. All right. Quotient rule says that if we have a log with a base of b and we are dividing two quantities, like m divided by n, well, let's see here. If I can expand a logarithm through addition when I multiply, what do you think we can expand a logarithm through when we're dividing? Exactly, subtraction. So that's going to be log with a base b of m minus log base b of n. So this is our quotient rule. When we are dividing two quantities with logarithms, we're allowed to break them up over subtraction. Yep, bottom from top. Bottom minus top. So here we go. If I have log base 8 of x over 2, that is log base 8 of x minus log base 8 of 2, and you're allowed to leave it just like that. Well, that's a funky. There we go.
Does it work for decimal places too? Like,
What do you mean?
2x,
Of x over 3. Log base 5 of x over 3. Well, I'm dividing two quantities, so this is allowed to be log base 5 of x minus log base 5 of 3. It does also work for natural logarithms, so I could have the natural log of e to the 4th all divided by 8. Okay, I like this one because this has two things we have to do in here. The natural log of e to the 4th over 8. So I'm dividing, right? So I'm going to have the natural log of e to the 4th minus the natural log of 8. But does anybody see anything else that we can do to this one? Namely, in the front end of this, with this term right here? It's just equal to 4. Very good, Carly. Because remember, if you have the natural log of e to the something, it's just the something part, right? So in this case, since we have a natural log of e to the 4, this is allowed to be 4 minus the natural log of 8. Okay, power rule. Power rule says if you have a logarithm with a base b of m raised to some other power, okay? So log base b of m raised to some power. The power, the exponent, is allowed to plop down in front. And this is going to become P times log base B of M. So this is our power rule. As long as you're raising a logarithm to a power, it's allowed to, the exponent is allowed to come down in front. So there's our power rule. So, as some examples for you, if we did the natural log of x squared, well, this x squared is the power on the x, so I'm allowed to bring it down in front. So I would simplify this to 2 natural log of x. Okay, if I have log base 5 of x to the 4th, right, I have a power rule here. So the 4 is in the exponent, it's allowed to come down in front. So I can say this is 4 times log base 5 of x. If I have log base 2 of 4x to the 3rd, now this one is actually a combination of two things down here. Well, this cubed is being the power of the 4x, so it can come down in front. So that's equal to 3 times log base 2 of 4x. But I could still keep going with this one. Does anybody see it? Yeah, right. Good. Glad he's caught that. Threw this one in here. I can still keep going with this one. And this would be 3 times log base 2 of 4 plus log base 2 of x. And I could actually keep going some more. Well, if I distribute, I'll end up sort of back where I'm at. What's log base 2 of 4? Is that an easy number? Log base 2 of 4. 2 to the what power gives you 4? 2. There you go. That's what you ask yourself, right? So this whole thing becomes 3 times 2 plus log base 2 of x, and you can leave it just like that. Okay. One more in this category for power rule. What about the natural log of the cube root of x? I like this one because the exponent is not obvious. What is the exponent for the natural log of cube root of x? 1/3. Yeah, awesome. So you can rewrite this as the natural log of x to the 1/3 power. And now we can use the power rule. So it says that, okay, this can come down in front. So this ends up being 1/3. Okay, we have log base b of x squared times the square root of y. So I see I see 3 things that we can do. All right. Anybody see 3 things that we can do this thing, or 1 thing that we can do to this? Yeah. What do you see? Which rule do you see? Name the rules you can see. Yeah.
A multiple.
A multiple? Which one's that?
Multiplication.
So a product rule. What else do you see? A power rule. I see 2 power rules, right? So I see 2 power rules and a product rule. Do you see 2 power rules and a product rule? Okay, so first let's start with the product rule. Okay, I am multiplying 2 quantities together, so I'm going to expand that over addition. So that's going to be log base b of x squared plus log base b of the square root of y. Okay? Yeah, Carly. No, not in this case, because I'm not squaring the y. If I was, then it would. Yes, Alan.
Is 2 log base b of x the same thing as log base b of x squared?
Yes, it is. That's my next move. This is my exponent, so it's going to come down in front. That's a power rule, so I'm going to have 2 log base b of x plus log base b of y to the 1/2.
Can you just do 1/2?
Yes, but I'm doing 1 step at a time to show you exactly where all these things are coming from. So here's my 1/2. Plop down in front. So my final answer is 2 log base b of x plus 1/2 log base b of to the 4th. Okay, yeah, go ahead. So log base 6 of the cube root of x all divided by 36 y to the fourth. Okay, I see 1, 2, 3. I see 4 things that we can do to this thing. Actually, I see 5. But that fifth one's kind of hidden. Nate, what do you guys see when you look at this? Carly, what do you see?
Well, the top one's the power rule, and the bottom one's the power rule and the product rule. Then the whole thing's like the quotient rule. And then when you expand it, you can probably simplify the log base 6 to the 36.
Dang, you hit all 5 right there. It says there's a quotient rule, there is a product rule, there's 2 power rules, and there's a simplification or evaluation of a simple log base 636. Great. So we see all these things in here. Now we got to start to untangle it, right? So first, I'm going to deal with the fact that I'm dealing with a quotient. So I'm going to give myself some room to breathe. Log base 6 of the cube root of x minus log base 6 of 36y to the fourth. So far, so good? That's just a simple quotient rule, breaking these things up over subtraction. Okay, now, what's the way I could rewrite the cube root of x? X to the 1/3. So that is log base 6 of x to the 1/3. Very good. Minus log base 6 of 36 times y to the fourth. Okay, now, let's see here. This part right here, this is a product rule. I'm multiplying the 36 and the y to the fourth. And then this right here is a power rule. So I'm going to do 2 things in one for the next line. I'm going to say this is 1/3 log base 6 of x minus log base 6 of 36 plus log base 6 of y to the fourth. Is that fair enough? So the 36 times the y to the fourth became that line down there. I've expanded that through addition because it's a product rule. You guys quote that part? Okay, good. What happens to this 4 now? And keep going. Where does this 4 belong? Yeah, now the reason I did the product rule first is because that 4 only belongs in front of the log base 6 of y, not in front of the log base 6 of 36. And the reason I know that is because this 4 is only the exponent to the y, not the exponent to the entire product. So therefore, I'm going to have 1/3 log base 6 of x minus log base 6 of 36 plus 4 log base 6 of y. And then the last and final piece, last and final piece is this part in the middle. What is log base 6 of 36? That is the number 2. Very good. So I finally have 1/3 log base 6 of x minus 2 plus 4 log base 6 of y. All right, awesome. Okay, we're almost done. You guys are doing a great job. I really appreciate it. So now we're going to go the opposite direction. We're going to go from an expanded logarithm down to a single logarithm. And when we do this, we want to make sure we have the same bases here, which we do. We have a base of 4, so that means we can continue. So I have log base 4 of 2 plus log base 4 of 32. Well, if I am adding 2 logarithms together, how can I condense them to a single logarithm? Multiplication. Very good. So log base 4 of 2 times 32. Well, how much is 2 times 32? 64. So log base 4 of 64. Is this an easy log to evaluate? Sure is, because you got to ask yourself, 4 to what power will give you 64? 3. Nice job. So the answer to this thing is 3. So that one's really easy. They're not all going to turn out to be nice, simple numbers like that, but this one happens. Base 5 of x. Okay, I have log base 5 of x minus 3 minus log base 5 of x. What am I doing to these 2 logarithms? I am subtracting them, right? So how can I condense 2 logarithms to 1 through subtraction? Quotient rule, and you got it. So this is going to be log base 5 of 4x minus 3 all over x. Yeah? Easy enough?
Why wouldn't it be 4x over -3?
Because this part right here, this is a single logarithm, right? And there's no rule that says I can expand subtraction. I can only expand division. Okay? Okay, so part C. Here we go. What if we had 2 natural log of x plus the natural log of x plus 1? Okay, question. Where does that 2 belong?
Exponential.
Yeah, it belongs in the exponent, right? So this 2 belongs right up there. That's where it came from, right?
So is that not connected?
So I'd have natural log of x squared plus the natural log of x plus 1. Lauren, what's my next move? Nah, sure. Okay, help her out. What's the next move? Yeah, Carly, what do you see? Product rule, yeah. I'm taking this natural log and that natural log, and I am adding those 2 natural logs together. If I'm adding 2 logs or natural logs together, we can condense them to a single log using multiplication or the product rule. So I'm going to have the natural log of x squared times x plus the natural log of x. Okay, I see 2 things going on in this particular case. 2 things. Who can tell me where that 3 came from? So now, what do you think?
The x plus 5 was cubed.
Yes, it came from the exponent on the x plus 5. So this part came from this exponent. So therefore, it's going to be the natural log of x plus 5 all cubed minus the natural log of x. Okay, so now, if I have a subtraction sign between the 2 natural logarithms, what do I do? A quotient rule. You got it. Very good. Natural log of x plus 5 cubed over x. E of y. Holy cow. Look at this thing. Look at this thing. All right, our goal is to make this logarithm a single logarithm. Right now, it's 3 logarithms. But they all have the same base, so we're good to go. All right, how do you guys want to start this thing? Move the exponents up. I think that's a great idea. So this exponent came from right here. This exponent came from there. And this exponent came from there. So let's move all those up. So I'm going to have log base 6 of x to the 4th minus, yeah. Oh, sorry, a b. Sorry, yeah, that's a b. Log base b of x to the 4th, sorry. Minus log base b, this is a 6, of 6 squared. Minus log base b of the square root of y. Is that okay if I do that? Yeah, because y to the 1/2 squared away.
So should you do that then?
Yep, you should do that. You should definitely do that. Okay, but here's the problem. Okay, the problem is we can't have a double quotient. Right? We can't have a double quotient. So what we want to have is a single quotient. That means that we need a single subtraction sign. So here's what we're going to do. We're going to do a sneaky little algebraic move. This is the key step right here. All right? Here's what I'm going to do. Watch this. I'm going to say log base b of x to the 4th minus, and then I'm going to put this part in parentheses. Watch this. Log base b of 6 squared plus log base b square root of y. Now, oh yeah, we can do 36. We're going to get there. But I want to focus on what I did rather than the 36 part. Why is this still okay to do? And why is this better than what we had before? What do you see, Carly?
Well, because if you use the product rule on the brackets, and then like you distribute the negative after you do that, then it makes it more. Wait, how
Yeah.
do you still subtract?
Yeah. So does everyone agree? Do you agree that this line right here, when I distribute the minus sign, is algebraically equivalent to the line above it? So that means I haven't changed anything.
Wasn't there already a minus sign there? So if you took one out.
Okay, so that being the case, why is this better now? Yeah, this is better for us now because I can rewrite this stuff inside the parentheses using the product rule. So that's what I'm going to take care of my 36. So I will have log base b of x to the 4th minus log base b of 36 times the square root of y. Now, I only have one subtraction sign, which means I only have one quotient. That's good news for us. So my next line is log base b of x to the 4th, all divided by 36 square root of y. And I have written that as an entire single logarithm. Okay, in your calculators, everybody, in your calculators, evaluate for me log 10. What do you get inside the calculator, log 10? Yes, you should get that, right? So when I push this on here, check it out. So clear this. If I do log 10, of course I'm going to get 1. Why am I going to get 1 back from this? Yeah, because this is log base 10 of 10, and 10 to the first power gives me back 1. Okay, good. What is log 0? Or sorry, log 1. Yeah, there you go, right? Again, same reason. If I do log 1, put in it, of course I get back 0. And how come that's the case? Yeah, because anything to 10 to the 0 power gives back 1. Okay, so the question is, what is log, these are all base 10. What's log base 3 of 7? Okay? A number. Of course it's a number. That's a very, very vague answer, right? Now, let's explore this just a little bit, right? Now, I know that 3 to the first power gives me 3. I know 3 to the second power gives me 9, right? So my answer has to be between which two numbers? 1 and 2. Is it going to be closer to 1 or closer to 2? It should be closer to 2, whatever this number is, right? But the problem is for us and these older calculators, we don't have this. We don't have a base 3 in our calculator. So I'm going to teach you two things. One, I'm going to teach you the change of base formula, which is the way we old folks used to do it before these new calculators came out, which have an awesome log base button, which I didn't know about, which is why like half of you are like, why is we know this, right? I didn't know about this button. You guys taught me something today. However, backing up a little bit here, the change of base formula is pretty sweet because it works on any calculator regardless of that button. It even works on your phones, okay? So if you have a log base b of m, something different than a base 10 for your calculators, you're allowed to break this up and say this is log base a of m over log base a of b, where a is any base that you want. Yeah.
Can you do this in numbers?
Yes, of course. Yeah, I'll get there, okay? In fact, I'm going to do this one, log base 3 of 7. The cool thing about this is that the b or the base can be anything that you want. It's the most amazing fact ever. Well, we're not the most amazing fact ever. We already had that one. So here's what I mean by this. So log base 3 of 7 can be into the calculator. Log base 10 of 7, since our calculators are in a base 10, it'd be sweet to just use that base, divided by log base 10 of 3. So we already did some analysis and said, okay, well, our answer has to be between 1 and 2. It has to be closer to 2. So I'm going to guess like 1.7. That's just my guess, okay? So here's how we'd figure this out. I don't have a base 3 in my calculator, so I'll use the change of base formula and figure out this is log base 10 of 7 divided by log base 10 of 3 and hit enter. Oh, look, 1.77.
Where'd you get 3 and 2 from?
Where did I get 3 and 2? There's no 2 on here anywhere.
How do you guess what's in between?
Oh, that, the 1 and 2. Okay, so here we go. Because this says 3 to what number gives me 7? Well, I know 3 to the first gives me 3, and 3 squared gives me 9. So 7 is in between 3 and 9, so my answer must be between 1 and 2. Does that sound good? Okay. Now, here's the cool thing. Let me show you something else. I'm not lying when I say you can use any base. Watch this. I'll use a base with a logarithm of the base of e. What's that called again? A natural log. Check it out. The natural log of 7 divided by the natural log of 3. Holy crud, it gives you the exact same answer. That's how cool the change of base formula is. You can use any base that you want. That's pretty awesome. Now, for you guys with the fancy schmancy calculators, clear all this out, go math, And then if you go to option A, which I don't have an option A on my calculator, but you'll find an option A on some of your calculators. It's called log base. Yeah, alpha math, right?